Good afternoon. Welcome to our CPD on designing to net zero. We're speaking from the kitchen of our new offices in Guildford. I'm Anna. I am one of the co-founders of SRE and the managing director.
I'm Elsa, and I'm a building physics consultant specialising in energy and compliance.
And I'm Sophie, a senior building physics consultant in the environmental modelling team.
We've been overwhelmed by the response we've had to our current series of CPDs. I think we've got over 200 people signed up for today, which is great. However, we are aware that there's going to be a huge range of the level of technical detail that people are wanting to get out of this CPD. I'm sitting next to two highly technical experts who wanted to include a lot more detail that we have put in because we wanted to strike a middle ground. But we are going to put all the technical detail into a briefing note that we'll be sending out in due course as well. I think we're all aware of the huge challenges that are being posed by the increasingly stringent regulations around sustainability in the built environment. I think we're also all aware of the need to work together and to collaborate on our joint journey to net zero. Many of our clients in recent months have been asking us what they can do to ensure carbon reduction is prioritised at the earliest design stages of any new building or new retrofit project. I can't tell you, but this is music to our ears. Over the nearly 20 years that we've been doing this, we have found that actually it's exactly this prioritisation that leads to the biggest cost and time savings in any project, as well as the whole host of other benefits. This CPD is going to go on, but we're going to talk for about 25 minutes, and then there'll be 20 minutes at the end of the presentation to take questions. Dominique's joined us here. She's going to be collating any questions that you want to put in the chat, but also there'll be time for you to ask questions over mic. We're going to start sharing our slides now. There are often a number of misconceptions around the term net zero, so we're going to start off by defining that. We've separated our recommendations for designing out carbon into the relatively new embodied carbon considerations and then the operational carbon. I want to point out now as well that most of our recommendations are applicable both to new design and to retrofit projects. Minimising carbon isn't always going to be possible for every development, so offsetting is going to be needed. So we'll touch on that. And as I've already mentioned, it is regulations and policy that is driving a lot of these changes. So we're going to talk about existing regulations, but also some that are coming down the line. And we're hoping that by the end of this CPD, the term of decarbonisation is going to be demystified and what we can do about it, but also you'll have an understanding of the real benefits of engaging in this debate as early as possible in any designing project. Sophie.
Thanks, Anna. Firstly, what is net zero? Net zero is when the sum of greenhouse gases produced by a building is equal to or less than the amount it removes from the atmosphere. We hear carbon talked about a lot, but what we're actually talking about is all greenhouse gases, which are commonly known as carbon dioxide equivalent. Net zero takes into account both embodied and operational carbon over the entire life cycle of a building, and we'll define these terms in the next slide. Removals relate to the sequestration or literal removal of greenhouse gases from the atmosphere. In the cases of buildings, this would be primarily done through the use of timber elements. Any residual carbon emissions should be offset through either on-site PV generation, for example, or off-site through a range of offsetting methods.
The carbon emissions in buildings are broken down into embodied carbon and operational carbon. If you attended our WLCA presentation last month, you should already be familiar with embodied carbon, but for those of you who don't know, it's the carbon associated with the materials and the construction processes. It is split into upfront carbon, which is the carbon from construction all the way through to practical completion, your building operational embodied carbon, which is the carbon from the replacement, repairs, maintenance and cleaning of the building during its lifetime, and the end-of-life embodied carbon, which is the carbon associated with the disposal of materials, whether they're sent to landfill or can be reused or recycled.
And then operational carbon refers to the energy used during a building's operation, and this can be separated into the two categories shown. Regulated energy comprising of fixed building loads, including heating, cooling, lighting and ventilation, and unregulated energy, which consists of small power equipment like TVs, printers and computers, as well as building loads such as lifts and fire alarm systems.
The sum of the embodied carbon and operational carbon over a 60-year period gives the whole life cycle carbon of a building. I'm going to pass over to Anna, who will break this down further.
What we're trying to show here with this diagram is two things. First of all, we are expecting both the operational and the embodied carbon of any development to reduce over time. Embodied carbon, obviously, because we're thinking about it much sooner in the design process, we can design it out. But also more and more low carbon materials are becoming available. With operational carbon, I'm sure everyone's aware of the decarbonisation of the grid, which is fantastic, but also more and more M&E systems are becoming increasingly efficient. You'll also notice that the relative weighting between embodied carbon and operational carbon is changing over time. And this is because, again, due to the greening of the grid, embodied carbon is going to become increasingly more important as we're trying to reduce our carbon emissions. So we're going to kick off with looking at how we can reduce them in design. The most obvious way to take carbon out of our built environment is to build less. We need to be retrofitting wherever possible. When retrofitting isn't possible, we need to be reusing materials on site. This picture that is shown is actually Cathedral Hill Industrial Estate in Guildford. It's one of the multi-award winning projects that we've worked on with Savills. And we advised on how to retrofit that to a very high standard. And again, reusing materials on site, which was something that we did a lot of. Simplifying design is another way of designing out embodied carbon and thinking about minimizing the use of finishes and using things like exposed ceilings or polished concrete.
Build light by reducing loads. A significant proportion of embodied carbon is contained within a building structure, with most of it coming from the floor build-ups. Traditionally, flat slabs have been a common choice due to the simplicity and ease for installation. However, they can be inefficient, with much of the material not contributing structurally to the building. These dead weights can be reduced by using lighter structural elements. For example, on the left, we have hollow core slabs, and on the right, we have two-way slabs on beams.
So we should build wise. While cheaper materials may seem initially attractive, it's important to consider their longevity. For instance, opting for durable materials reduces the number of times they need to be replaced during the building's life. Or using mechanical rather than adhesive fixings means that plasterboard, for example, can be demounted and reused at the end of the building's life. It is also essential to balance operational and embodied carbon. For example, the upfront carbon of some retrofitting measures may actually be greater than the intended operational energy savings. We looked at this for Langtree on some of their warehouses, like the one shown on the slide, and we found that the upfront carbon, that improvements to the fabric, resulted in a payback period of around 15 years, but improvements to the fabric along with the installation of PV actually dropped the payback period to around 5 years, despite the increased upfront carbon from the PV.
Thank you, Elsa. Once we have minimised material usage, we need to be thinking about using low carbon materials. Again, more and more are coming onto the market all the time, which is great, but trying to steer away from high carbon materials and using natural or renewable energy, renewable carbon is great. Also, one thing to bear in mind is that it's the entire life cycle of a product that needs to be thought of. So bricks, for example, they use a very high energy intensive way of manufacture, but they've got very long life expectancy. So over the lifetime of the bricks, it's actually much lower than some products. Off-site construction is another way of reducing embodied carbon because it can lead to less wastage and less energy use on site. We've worked with Hoof House since 2007. This is actually their show house in Weybridge, and they obviously use off-site construction for their very high-performing and luxury houses. Another client that we have, Stelling Properties, they use off-site construction for student accommodation.
So buildings should be designed for the future and for their adaptability and deconstruction. Designing with clear spans and non-load-bearing internal partitions creates flexible open spaces, allowing for multiple alternative uses. So for example, shops can become offices, and we've even had one project where bank vaults become a flat. It is also essential to design for future climate conditions, so anticipating rising temperatures can reduce the risk of increased cooling loads in the future. And finally, and a bit more of an exciting one for the architects listening, is incorporating beauty and quality design can help ensure a building's longevity. If a building's captured the hearts of the people who live and work in it, they're more likely to maintain it, and people are more likely to fight for it to be adapted and reused at the end of its life.
And actually this picture here is a picture of a project of another of our clients, Kinrise, and they specifically use and repurpose historical buildings. And last but not least, when we're looking at embodied carbon, building collaboratively is absolutely important. The entire design team needs to be involved in designing out carbon. It's not just down to the energy consultants, and it needs to be from day one as well.
Before we go into the details of designing out operational carbon, we need to consider the highest energy loads for different developments. Offices tend to have high lighting, heating, and cooling loads, whereas warehouses, which have large unconditioned spaces with no heating or cooling, predominantly have high lighting energy consumptions. Industrial units may have bespoke machinery and equipment, leading to high unregulated energy loads, and residential units, including student accommodations, hotels, and care homes, generally have high heating and domestic hot water demands. Therefore, it's important to focus on carbon improvements to specific aspects of your development when designing to net zero. To get there, we're first going to look at some passive design measures which should be considered during REBA stages 1 to 2. Starting with building orientation. Main habitable spaces should be located on the south facade with larger glazing to maximise solar gains and internal daylight levels. Fixed shading devices such as horizontal bins or balconies can be used to block the high summer sun, preventing overheating, but allowing the low winter sun for positive solar gains. The southwest orientations have the highest risk of overheating due to the low angle of the afternoon sun. Therefore, try to reduce glazing where possible and potentially incorporate vertical bins or shutters. Rooms where view out and daylight are less important, for example, bathrooms, storerooms, or spaces for building services, should be located on the north facade. If necessary, clerestory windows, as shown from the top image, can be used to increase the internal daylight levels, whilst minimising the heat losses that would otherwise be associated with larger glazing. Whilst considering the room positioning, you also need to consider simplifying the overall building mass. As shown from these images, to reduce heat losses and energy demand for space heating, design a lower external surface area to volume ratio. Therefore, we suggest emphasising a few key design features that really matter in the context, reducing your surface area and in turn the number of non-repeating thermal bridges. But what are thermal bridges, Elsa?
So thermal bridges can be the weakest point in a building envelope where there's a break in the continuous insulation. They occur at junctions, so this is one we've calculated for a wall-to-floor junction. And if you want to learn more about minimising thermal bridges, we're actually doing a CPD on the 30th of May. But for the sake of this CPD, if you just focus on minimising the number of them by simplifying the building form.
Sophie mentioned when she was talking about orientation, the need to consider window to wall ratios. Letty produces guidance on that and based on window to wall percentages based on orientation and building use. We often find that architects design very beautiful vertical windows, but experience has taught us that horizontal windows do bring with them a lot of benefits. Firstly, they ensure a more even distribution of daylight, which can reduce the load for artificial heating. They also increase the openable areas for ventilation, which can obviously reduce mechanical ventilation requirements. But also they are more easy to shade, which again then can reduce the cooling load during the summer. But when we're designing windows, obviously glazing is an important issue as well. Thinking about U values, I'm sure all of you know, measure thermal transmittance through any structure or any building material, but heat loss through windows can be up to 4 times greater than any other building material. So it's really important when we're thinking about designing to net zero to achieve as low a U value as possible for windows, and that is obviously with triple glazing. Again, something that we've noticed over our 19 years of doing this is the increasing emphasis on G values. G values is obviously solar energy transmittance, and it's really important to balance the need for heat gain during the winter, but also the risk of overheating during the summer, which is becoming increasingly a problem as we're facing climate change. Again, when replacing windows isn't an option in retrofit projects, there are films that you can get to coat windows to improve G value ratings.
So as Anna's mentioned, U values relate not only to windows, but to the whole building fabric. It is important to very early on establish the installation line for the building and ensure conditioned spaces are well insulated. Cold spaces should be grouped where possible towards the north of the building ideally, and in some buildings it can be worth considering insulating these cold spaces to future-proof them for alternative uses. As buildings become more insulated, airtightness is increasingly important. Airtightness grommets should be used around cables and pipes, and tapes around openings. And Passive House actually recommends doing 2 airtightness tests. So one when the air barrier is still exposed, and then again at practical completion. Another area to consider in the building fabric is thermal mass.
Thermal mass describes a material's capacity to absorb, store, and release heat. Thermal mass can be used to absorb heat during the day, preventing overheating, and release it back into the building at night when it is cooler outside. Timber and steel frame structures are classed as lightweight and therefore have a low thermal mass, whereas high mass constructions would consist of concrete, brick, or stone. As a warning, if you use high thermal mass, it can be counterproductive, as during the winter months, it can increase your heating demand as heat gets trapped in the building fabric. Please also note, plasterboards and carpets can cover thermal mass, reducing its effectiveness to absorb and release heat. Therefore, we would recommend using exposed mass where possible, otherwise opt for wet plaster or tiles. Now we have covered some of the passive design measures, we'll now go on to discuss active design measures.
So as we all know, to get to net zero, we need to move away from fossil fuels and move towards low and zero carbon all-electric solutions. Currently in the UK, the most viable options are air source heat pumps and ground source heat pumps to provide space heating, cooling, and preheat domestic hot water. Air source heat pumps are around 2 to 4 times more efficient than a standard electric panel heater. Ground source heat pumps are more expensive, have installation challenges, and increased embodied carbon, but are more efficient than air source heat pumps.
There's often much discussion over the relative benefits of individual and communal systems. We're obviously talking about heating, cooling, hot water, and ventilation when we talk about these. Communal systems often are more energy efficient because they can benefit from economies of scale, and they're often easier to connect to district heating networks as well. However, there are drawbacks, and one of them is the long pipe runs. So again, we need to be thinking about minimising pipe runs and insulating pipe work wherever possible. There's also something that we have found, especially in a lot of the student accommodation that we've worked with, or care homes, that a lot of the communal areas where the pipe runs go do suffer from overheating. So again, that's something that might be considered a drawback of communal heating systems.
Energy efficient designs for domestic hot water should be adapted based on the building use. To reduce heat losses and hot water consumption, consider chemical treatments such as chlorine dioxide or UV treatments to safely control Legionella bacteria at lower water temperatures, meaning that it works well with heat pumps. Minimize pipe runs by grouping and stacking wet rooms where possible, and consider installing wastewater heat recovery systems and flow restrictors to further reduce that hot water consumption, both of which are great for retrofitting existing buildings. Some of you are probably wondering why solar water heating isn't mentioned here. The reason being is because it relies on solar radiation rather than sunlight, which is used by PV. So to maximize your roof space to achieve net zero operational carbon, first consider PV installation for greater carbon savings, and then consider solar water heating for the remaining area.
So to keep this presentation to under 25 minutes and not overwhelm you with too much information, we've just briefly summarised lighting, ventilation and unregulated energy. So lighting accounts for around 5% of global carbon emissions, and as Sophie mentioned earlier, in some buildings can be the highest load. To reduce lighting energy consumption, focus on ensuring good daylight, using highly efficient LED lighting and well thought out sensors, so PIR and daylight sensors. As buildings are becoming more airtight, mechanical ventilation is required to help the building breathe. And while ventilation energy demand is generally quite low, ventilation can result in significant heat losses, with warm air leaving the building and cold air entering the building. Heat loss will recover some of this heat, and this can be further optimised through the use of demand control ventilation with CO2 and occupancy sensors. But in summer, natural ventilation through openable windows where possible is the ultimate low energy solution. And finally, unregulated energy can have a significant energy load in some buildings. And what's most concerning is actually the amount of energy used outside of operational hours, which in some schools and offices has been found to account for 40% of the total energy consumption.
Which is crazy.
Bearing this in mind, some of our top tips for reducing unregulated energy are smart controls in power systems, checking the EPCs for appliances, and moving IT servers to the cloud.
And turning everything off at night. Yeah. So
once a building's operational energy consumption has been minimised as far as possible, the residual energy should be offset by maximising PV on site. This can be achieved by avoiding installation on north-facing roofs and avoiding overshading from surrounding buildings and trees. If the PV energy generation is greater than the energy demand on site, the excess energy can be exported to the grid. However, it's important to check with the local power station to see if they have the capacity to deal with this electric load. Otherwise, battery storage can be used. External roof terraces and plant equipment installed on roof spaces can limit the area for PV, whilst also increasing the structural load on the building. Therefore, think back to build light to reduce embodied carbon.
thank you, Sophie. So just really briefly touching on offsetting, as much as we can do in the design, there's sometimes going to be an element of residual carbon emissions which do need to be offset if a development is going to get to net zero. There are two ways of offsetting it. Sometimes when a company has multiple sites, they can, where some sites are kind of more easily sorted out in terms of the energy usage than other, they can offset in one to compensate for the energy usage in another. Similarly, as you probably know, carbon credits can be bought, and they can usually go into nature-based solutions or technological-based solutions. Nature-based solutions tend to have much more advantage in terms of biodiversity and a lot of those that go with it, although the technological-based solutions, there are more and more coming on the market all the time. One of the things, again, that is happening, and I know we've touched on it, is the more and more stringent regulations. The GLA seem to have been setting the highest bar. And what we had thought is that then gradually other planning authorities would develop their own planning policy. But what we're finding increasingly is that a lot of the authorities, not only in London but outside, are just turning towards the GLA and referring to their levels of policy. I think we all know of the Future Home Standard and the Future Building Standard, that both coming into effect in 2025. The first obviously relating to residential property and the buildings to commercial.
So outside of building regulations, a UK net zero carbon building standard is currently under development, and once established can hopefully serve as a basis for verifying whether a building achieves net zero carbon, and will hopefully be integrated into various tools in the industry. For whole life carbon assessments, RICS have their second edition, which provides the standard and the benchmarks for completing a whole life carbon assessment. And finally, on this slide, we just kind of listed a few sources of key guidance, which you can refer to for more details on net zero.
So we've given you a whistle-stop tour of some of the design considerations that need to be thought of. We're going to be designing to net zero. Who has got any questions? Dominique, have some come through in the chat? Please unmute yourself and ask any questions. Or you can pop them in the chat. It's probably because there's quite a few people.
Yeah. No questions in the chat.
Is there any area that we should have talked more about? Else there's 3 points that we put onto one slide.
Hello, can you hear me?
Yes, I can. Congratulations for being the first.
I thought somebody should say something.
Yeah.
Hi, it's Adam West. And it's a general question, really. There's a lot of talk about embodied carbon in the sort of the building fabric and so on, and trying to improve that. And obviously, as you pointed out earlier, that's becoming more and more critical. I suppose my question really is, all this kit that we've got to put in buildings now, the sort of the extra M&E, how much work is being done on working out what the embodied carbon of that kit is? You know, the heat pumps and the PVs and all the other kind of the issues around sustainability, the materials of PV cells and so on. Is it just that that's much smaller than the kind of the amount of embodied carbon in the building fabric, that it's kind of meaningless? Or
no, not at all, and that's a really good question. And often it comes up with, you know, with the case of triple glazing and the embodied energy in that, and sometimes we might not specify triple glazing, it might be double because of that. Actually, on one of the projects that we work with for one of our big clients, we were looking at getting to net zero, both operationally and embodied. In the first project we did with them, they did have a lot of solar panels and they had Tesla batteries. And what we learned from that is actually that it was because they couldn't connect to the grid, which is a situation for a lot of new developments, sadly. But what we then did with their next project is we actually specified much less PV, and we used, because of the embodied carbon of the other ones that had come from abroad, there is actually a producer of PV panels in Cambridge, and this site was quite close to Cambridge. So we actually didn't use the Tesla batteries and we used less PV, and we had much better embodied energy stats than we had on the first one. So yes, it is something that is taken into consideration, and you know, the sourcing of these products is just as important as well. I don't know if you two have anything to add. You probably do, Elsa.
I mean, it is taken into account in the one-click which is where we do our whole life carbon assessments. You can put in systems. It will depend on, sometimes we have to make assumptions if they don't have that specific kind of heat pump on there. We have to make an assumption of a similar one. And as kind of Anna touched on, it's important from where it's been sourced from. So the transport to site is something that we have to make sure we put in as accurately as possible, because it can have a big impact on the embodied carbon of the building.
Yes, presumably flying things, sort of shipping things in from China
Yeah.
doesn't really help with that, does it?
Yeah. So embodied carbon is going to be great for British industry. We're hoping.
Yeah.
Thank you. That was a really great question. Anything else?
We have a question in the chat from Jack, and he says, firstly, thank you for the presentation. He's asking if we are trying to establish at the outset of a project whether to refurbish/retrofit or demolish for a new build, is there an easy metric or checklist that we should be considering when analysing an existing building?
Good question, Sophie.
Yeah, so during the early design stages, it's best to have those discussions to figure out what can be reused of an existing building to determine whether it's best to keep and reuse and retain elements and then retrofit, or whether it's then easier to knock it down. We would prefer keeping it there if possible, because that obviously reduces the embodied carbon aspect further down the line, reducing the material that you're going to have to use. And then when it comes to the operational side, including the ventilation, what we would suggest is even just replacing windows can make a building a lot more airtight and increase that, which means improving the efficiency of your heating systems, ventilation systems. And as our buildings get more airtight as well, it's important that we include these mechanical systems so that buildings can breathe, because at the moment where you're trapping heating, it's not able to breathe as much, and you're not getting that natural flow of ventilation. So yeah, it's important to include that.
Does that answer your question? We've got another question here about designing to net zero. What's your suggestion on the natural passive heat recovery and mechanical ventilation options at the early design stage of a project? Elsa?
What's your suggestion on natural passive?
We're looking at natural passive heat recovery and mechanical ventilation options at early design stage of a project.
So generally, as buildings are becoming more airtight, if you're getting an air permeability of below 3, it's recommended to use mechanical ventilation. However, as we kind of mentioned in the summer, even if you have mechanical ventilation, having natural ventilation through the window will help reduce the energy load for the fans to get the mechanical ventilation.
There are actually alternative passive design measures that can be used, which can be designed early on during like planning out what the floor plans are, as there's air tunnels and wind catchers that can be incorporated into your building design, which are a more passive way to help with the ventilation strategy and also with heating and cooling in the summer and winter months.
That was one of the slides we took out.
But
yeah, there is a very, very high profile hotel in London on one of the squares that is using a similar kind of underground ventilation system to get hot air out of the building as well. So yeah, it is being used more and more.
Any other questions?
What are the biggest hurdles with existing buildings when trying to achieve Passive House Golden or Silver accreditation? Elsa, you're our Passive House champion.
So I think for existing buildings, we've worked on one, I think a couple of years ago, and it was actually the airtightness was one of the key challenges, getting the airtightness down to the standards for Passive House. It's very hard. Then what other challenges?
Airtightness.
Yeah, I think
airtightness is
the
the main.
There are actually paints that you can use now, which are airtight membranes, which are becoming more common to help get to Passive House standards as well. So yeah, it's worth looking into that as well to help. get your building to where it needs to be.
Ironically, we did do quite a large development we advised years and years ago on passive house for social housing, but now there's an overheating problem that wasn't envisaged, you know, that long time ago. So yeah, it's a kind of a balance, isn't it, as we've been talking. Any other questions?
Hi, it's Neil from Askia Construction. At what
Hi,
stage?
Neil.
Hiya. What stage are you being appointed, and is there a requirement, a bit like with BREEAM, where you get appointed sort of almost a conception stage to enable the project to meet you know, carbon zero? I mean, we're currently working on a passive house scheme and a carbon zero scheme, so we've got it all going on at the moment, which is great experience for the company and the team. But the net carbon zero requirement for the scheme we're building was actually introduced after appointment for us, so it's been it's been a bit of a challenge, put it like that. And is there a requirement for it to be, you know, for you to be appointed sort of right at the beginning? Because a lot of our projects, obviously, are design and build, come with various stages of design, and obviously it needs to be captured early, like BREEAM, where you need to consider every decision that you make really within the building, but we don't always have that influence until appointment.
So yeah, so it's not necessarily a requirement, but it's definitely better to, well, the earlier on to get involved, because I mean, like Sophie mentioned, with windows play quite a big role, and later on in the design they're often fixed. So the earlier on you can get involved in kind of just providing some initial feedback, not necessarily going into the details, but just kind of red penning essentially some of the drawings can make a big difference.
We've had a number of meetings with a lot of our clients we've worked with for a long time recently about what we can do, you know, where in the timings we need to come in. I mean, at conception stage, it's usually quite a good idea. We've been talking to someone about that, but yeah, you're going to have much lower costs and much less time involved if this kind of detail is thought about as early on as possible.
Yeah, and we know that the design does evolve in the earlier design stages. So what we generally do sometimes is do some modelling, initial modelling, to give some feedback and recommendations. And then as the design evolves, then all of those feedbacks can be implemented into the design, in which we would then rerun the modelling calculations to figure out, okay, how is it performing now? And are there any further things that we need to do to improve this building?
So is that the REBA stage 2 building components schedule that you complete from the conception?
Sorry, can you say that again, please?
The REBA stage 2 building, so that's the schedule that we're using on the net zero carbon project that we're working on. So
between REBA stages 1 and 2, we start to get involved generally at REBA stages 1 to 2. It's more just giving feedback on initial plans, whereas when we get into modelling, it's normally REBA stages 2 to 3.
Right, okay. So generally that would happen prior to tender, because we normally get it at sort of stage 3 to then, you know, develop the design during stages sort of 4A, 4B.
Yeah.
Okay. Thank you.
Thank you, Neil. Any other questions?
Is there one that puts in?
What programs are you using to calculate operational carbon in existing buildings?
So in terms of that, we do TM54 methodology, CPD methodology, and that is using IESVE, which is the software we use, and there's an Apache programming where we can model specific inputs with regards to the building's operation. And this is a lot more in detail than your standard compliance modelling. So that would be your SAT or your SBEM, which only takes into account the regulated energy. So yeah, we use that software to do the in-depth analysis to find out and to be able to achieve net zero operational, regulated and unregulated energy. So as we were talking about before, that's your small power equipment and your building load, on top of that regulated energy.
that make sense? I'm sorry our lights keep going on. We haven't worked, we're obviously new in our offices and we haven't worked out how to override the PIRs. Yeah. We've got a question here about zero credits, but when salvaging crushed concrete, do we know how many credits that gives you for a new structure?
So I'm not sure in terms of the credits. We just essentially we would kind of take it into account in a whole life carbon assessment. So you'll take it out of the embodied carbon, accounting for the fact that you're reusing materials on site. But yeah, I'm not sure in terms of credits.
Yeah, we'd have to check the numbers
Yeah, we can
and
get back.
Yeah.
Any other questions? I give that to you again. How much improvement on performance and efficiency can be expected?
Upgrading from current building regs to passive house standards.
Elsa?
Can you repeat the question?
Yeah, so how much improvement on performance and efficiency can be expected upgrading from current building regs to passive house standards?
So going from current building regulations to passive house, there is quite a big difference in the results. So Part L building regulations just looks at regulated energy. It doesn't take into account any of your unregulated, and it's fairly simplified in terms of its assumptions. So there is quite a big kind of improvement essentially from building regs to passive house, particularly in terms of U values in your fabric. However, the future home standards, which is coming in 2025, as Anna mentioned, is going to be a bit more in line with passive house in terms of their U values and airtightness as well, and the systems. But yeah, so there's quite a big jump. And thermal bridging as well is another big one. So the new building regulations for houses are looking at thermal bridging. Passive house does go into a lot more detail in that, particularly in terms of minimising thermal bridges. And the other big thing on passive house is you're actually, so now building regulations are starting to do photographic evidence to verify what you're building, but passive house again goes into a lot more detail, so you can be even more confident that your building is achieving those standards, because they will essentially your passive house designers do the modelling, then it's checked by the certifiers, and then it's checked by an external passive house organisation. So you can be very confident in the building if it's going for passive house. I hope, that answers the question.
That was a good answer. Any more questions? I think what we'll do is we'll pull today's session to an end. We would really love feedback. We're doing a whole load of other CPDs, and what we really struggled with today was how much technical information to put in and how long we should talk for, and the balance between the presentation and the questions. So we'd love feedback. Do email any one of us or Hazel at sre.co.uk. Thank you and goodbye from all of us.
Bye.
Bye.